Shimano engineers, Campy engineers, I pity them. They have to hang these quality parts on something that is a bag of crap. I mean, come on, we might as well just give up. Now, hi everyone, and welcome back to the channel. Now, in this little video, we're going to look at the 2021 Canyon Aeroad seat post disaster. We're going to look at the design intent, we're looking at the engineering mess up, and we're going to propose a fix with a bit of simulation and a few calculations. If you're a Canyon owner, I'm going to propose a few things you can do in the meantime whilst Canyon sort out the whole warranty mess. So stay tuned, and actually at the end of the video, I'm actually going to kind of read the riot act a little bit to frame manufacturers and basically frame brands, because they are letting the industry down, and my patience with frames is wearing thin, just like the Canyon seat post. Now, if you don't know what's going on, in the new Aeroad, Canyon have implemented a more flexible seat post. So they've got the clamp much lower down in the frame, and they've got a reduced cross section where the clamp actually clamps the seat post to the frame. So you get a larger unsupported length of the seat post to give you more flex, and it mimics a kind of sloping top tube design with a skinny seat post, but you have a straight top tube with an aero shaped seat post. Now, to be honest, it's a valid design. It's a little bit overcomplicated because you could just have a sloping top tube and an aero seat post just like a TCR or something. So it is a little bit complicated, but it is valid. Like, it's a good thing to do. Aero bikes have deep, stiff seat posts normally, and it really ruins the ride. It ruins the ride comfort, it ruins braking traction, and it ruins cornering traction when you're seated as well. So I'm all for flexible, soft seat posts. Also, you can go too far to the extreme if you don't want to be bouncing on the saddle with a really soft seat post. The design intent was there, it's just been executed extremely poorly, and we'll have a look actually at how easy it is to get right. It took me about 60 to 70 minutes to model all the parts, do the simulation, and actually evaluate how much clearance you need in the frame. So if you don't know what's happening, the seat post is clamped somewhere down the bottom, it's deflecting, and there's not enough clearance in the frame, and the back of the seat post clashes with the frame. And there's a kind of a bit of a cocktail of user error going on as well. People are trying to put like carbon paste on the back of the frame, which is making the problem worse because you get basically a grinding paste on the back of the seat post. There's no rubber grommet on the seat post, so dirt and crap can get down and carry on grinding paste away. We're going to look at the process of how easy it is to get right. And Canyon, if you're watching this, I've heard some rumours that you're going to make a tighter fitting seat post at the top with less clearance. If you're watching, like, please don't do that. I can guarantee it's going to be worse. Not only is it still going to fret because the bottom section is compliant, it's still going to fret on that area and cause damage, but it shows a real lack of integrity on your part, because you had a design intent in the first place to produce a flexible seat post which is clamped at the bottom, and then your solution as a fix is to brace it halfway up with some clearance and some backlash, and yeah, it's a horrible method. So my suggestion, as you'll see in the simulation, the engineering, would be to reduce that cross section where the seat post comes out the frame and possibly make it a little bit stiffer as well, and just do the calc. Just do the calc, like put the worst load case in, so the heaviest rider, highest seat position, maximum setback, put that into the load case, times it by 1.5G, times it by 2 for a safety factor, there's the clearance, rubber cap, job done. Anyway, let's have a look at the engineering. Now, before we get into the quick simulation, I'll just show you some pictures of the actual issue. On the left here, we've got an original CAD image from Canyon, and I actually did a big lol at this when it came out, because as you can see at the top of the seat tube, there is zero clearance. So they've designed this flexible element to the seat post clamped further down, so it's designed to flex, but then they've braced it at the top of the frame so it can't move. And originally when I first saw that, I thought that has to be some sort of artistic render, that can't be final production engineering 3D, because that's just not going to work. That's going to bind, this is going to cause damage. And lo and behold, it's exactly what we see on the image in the middle. This is a customer's photo, and you can see at the back of the seat post where it's just fretted, abraded and rubbed away. And the problem gets worse obviously if there's any dirt in there, but really that's not the issue. If Canyon say that is your problem and they're trying to patronise you with a warranty response saying you shouldn't ride in sandy or muddy conditions, well, that's their problem, not your problem. You should be able to ride the bike in any conditions, and the fact is there's just not enough clearance. Teaser of the simulation, this is what I modelled. I've got the frame, the seat post clamp bolt at the bottom there, and I'm running this like as far out of the bike as possible, so I'm a tall rider. The problem's going to be worse, and if you're tall and you're heavy and you run the saddle set back, there's more bending moment, higher bending component of your weight, and the problem's going to be worse. And this just goes to show you there is going to be a clash there, so you need to size that clearance for that deflection. Yeah,
And before we get into the simulation, I mean, you can do this calc by hand. You don't even need FEA software. I mean, I've modelled this stuff and done an FEA. That modelling took me about an hour. The FEA took me literally 10 minutes to put it together and simulate the deflection. Obviously, I don't know the exact dimensions of the seat post. I haven't got access to their drawings, but I've done it by eye. I think it's quite close. I've modelled it as, you know, black aluminium with a guessed Young's modulus or flexural modulus of somewhere between 80 and 100. But yeah, without the FEA, you can do this by hand. So all you need to know is the force, which is basically the bending component of the rider weight. Hambini showed you how to resolve forces perpendicular and in line with the beam. You need to know the length of the unsupported beam. You need to know the Young's modulus of the material. They should know that from the carbon layup. And they need to know the I, which is the second moment of error. Now, I've done a video on second moment of error and shape stiffnesses, so go and check my back catalogue for that. You can do that by hand calc, or if you've got a complex shape, you can do it from a CAD package. The CAD package will tell you the second moment of area. So for the load case, you need to take the biggest rider, the highest seat, and the maximum saddle setback that's possible, which will give you the largest bending component on the seat post. And what you cannot forget is this is not a statics problem. You can't just take the rider weight as, you know, 80 or 90 or 100 kilos, because you don't just have a static rider weight. When the rider hits a bump or a pothole, there's a serious G multiplier involved. So I've estimated that between 1.5 and 2G. Now 2G is a really, really extreme bump. That would be more of a jump and a hard landing. But 1.5G for a pothole is not an unreasonable assumption. So the force they need to do this simulation with could be up to around 200 kilos. If you're taking a rider, you know, 80 kilos, or you could end up with kit, obviously, don't forget, and then you times it by the G multiplier, you could end up in the realm of around 2,000 newtons or 200 kilos. That's not an unreasonable assumption. And what they need to do is size the clearance or size the deflection of the seat post for this worst load case. It's really basic engineering, and I'll show you simply how it's done. So first of all, I'm going to show you my model. Like I said, I basically scaled this model from what I could see in pictures and on the internet. I don't have a bike. I don't have a Canyon Aeroad, but here I've got the frame member. I've got the pinch bolt assembly pinching on the back of the seat post on that little face there. And then I've got the seat post with a nominal clearance of 1mm at the back of the seat post. Now, like I said, I've modelled the seat post by eye. I've used a kind of arbitrary wall thickness, but I think the chord length of the aero profile of the seat post is somewhere about right, somewhere between 40 and 50 mil. So I'm not claiming to have the second moment of area or stiffness of the seat post exactly correct, but Canyon engineers will have access to that. They designed it, so they can do this simulation better than I can. I'm not going to do it for free for them. Now here you can see the seat post in the frame. Obviously I've got a plot of displacement, and you can see obviously you get maximum displacement at the top and almost zero at the bottom, and I've got the pinch bolt simulated with the clamping area, so it's fixed on this pinch bolt and fixed just on a face on the front of the seat post as it would be in the bike, and then basically the rest of the whole length is unsupported and quite simply free to move. And you can see the effects of deflection. You get a clash, obviously what we're seeing in real life, you get a clash at the back of the seat post. I'm actually loading an animation right now to try and animate it, and you can see the seat post going through its motion, or its range of motion. Now obviously the stress in the seat post isn't that high. The max stress you get on the seat post is by the clamp, because that's where the max bending moment will be on a cantilever beam. So I'm not worried about the stress of the seat post. It's more just like it's damaging itself because they just haven't allowed for enough clearance around the flexing seat post. Or the seat post has come in way too flexible and not stiff as they intended it to be, and the supplier's messed up and made a very floppy seat post, and it's going through too much deflection and clashing on their nominal clearance. So here you can see that this animated deflection. This is exactly what's happening in the bike, and the problem gets worse the further out the seat post in the frame you run it, and the heavier the rider. And this is actually just simulated with 150 kilos. And yeah, like I said, I've guessed the wall thicknesses of these carbon members. I've probably made them a little bit thin because it's telling me at this area, at the back of the seat post, I've got around 20 mil of deflection, which is probably too high. But I wouldn't be surprised if completely unrestricted, it would be around 10 mil, something like that. I think probably the wall thickness of the seat post style model is a bit thin. I wouldn't be surprised if it's more like sort of 10 mil. So they have a real clearance issue they need to sort out. They need to make it, they need to make a much bigger hole, make the seat post much smaller so it has enough clearance inside the existing frames, or they need to work on the layout, work on the stiffness and second minimum area of the bottom pit of the seat post to make it a lot stiffer, because this is, you know, even if I have assumed some wall thicknesses, obviously I don't have the drawings, but even if I have assumed something incorrect, yeah, that's way too much deflection for what's in the frame, and it's a real clanger. So what do I recommend they do? Well, I recommend they make a seat post. The kind of quickest and least disruptive thing is they can't replace all the frames. That would just wipe them out. That's just, it's not feasible to retool the whole frames in every single size. So they'll have to retool for the seat post moulding and create a smaller cross-section seat post at this area, so there's just enough clearance in the frame basically, because they can't change the frames now. They can't get everyone's frames back really, so they're gonna have to work on the seat post. I would probably make it smaller so it didn't clash, and also make it stiffer so there's no risk of clashing. And then even then you're still going to have this orifice, this entry port for dirt and debris at the top of the bike, so you need to produce some sort of rubber grommet. Now every single bike or carbon bike I've had for the last 10 years has had some sort of rubber grommet on top of the seat post. Why this didn't ship with one, I really don't know. Normally the frame factory can outsource your 3D rubber grommet, you know, in a matter of days. You send them the 3D file from Germany and you send, right, I want 2,000 of these, I want them at short, rubber hardness, whatever, and bang, they'll open the mould, you'll get a sample, and I'm going to show you, all you need to do is produce a little rubber grommet like that sits on top of the seat post. It's tight fit on the seat post, and even if you can't be bothered to tolerance it properly to interface in a groove with the rest of the frame, just overlap it here like I've done here. So overlap it, so any water that comes down the seat post, there's a tight push fit on the seat post, so you make the rubber bit nominally smaller, so it's like a tight fit on the seat post, and any fluids come over and just drip down and over like a skirt basically. It's a very easy way of doing it. You really need to do this, Canyon. You need to do it soon.
So with that all dealt with, if you've got a Canyon Aeroad, what would I suggest you do in the meantime? First of all, absolutely imperative, open a warranty claim. Even if you don't see problems yet, you might do, and you're saving the next owner of your bike as well. So open a warranty claim so you're covered. Number two, set your seat height. Once your seat height is perfectly set, as an interim solution whilst you're waiting for whatever warranty change they're going to do, you need to basically go around that orifice where the seat post enters the frame with something like bathroom sealant, so silicone sealant. Now that's great because it actually creates a really good watertight seal, so no dirt and crap is going to get in there to continue the abrasion. Because don't forget, they might replace your seat post, but they won't replace your frame, so you don't want to damage the carbon on the frame. So go around it with some silicone sealant, bathroom sealant, that sort of thing. You can do it really neatly. You know, if you've got a white frame, you can do it with white one. You've got a black frame, you can do it in black, and that will create a really nice weatherproof solution until you get your warranty. I mean, the fact that I'm even saying to put silicone sealant on your £5 frame is ridiculous. But just do it in the meantime, because that'll help you. But get onto the warranty claim, number one. Now, just to cap the video off, like I said at the start of the video, my patience with frame manufacturers is really wearing thin. Like, my two passions, right, are cycling. Well, my main two passions are cycling and engineering. And one just doesn't keep up with the other one. I also have a hobby of cars. Like, I'm a car guy, I love driving, I love cars. I collect different cars, okay? So that hobby, they do go together. Like, I can appreciate great engineering in automotive, and I see it, and I can see engineering in practice in automotive. And yeah, it's a completely different industry, but when you're paying the amount we're paying for bicycle frames, they have to be made with I'm not saying aerospace or automotive standards, they have to be made with just like decent engineering, okay? And the other thing I'm gonna say is that your peers in the industry, frame manufacturers, your peers, I'm talking group set manufacturers like Shimano, SRAM, Campagnolo, say what you like about them, but they achieve much better manufacturing practices than you do for much less money, okay? So if you think about a carbon frame, a plastic frame, versus a shifter mechanism or a rear mech or something like that, think about how many moving parts there are, think about how many dowel pins there are, think about how many tolerance holes there are, think about the alignment that it needs to have, and think how repeatable one rear mech is compared to another one, right? That is exquisitely practiced. High repeatability, high precision, okay? You wouldn't accept two Ultegra rim brake calipers that had a different friction at the lever, because the dowel pins were slightly different, or the holes on the pivots were slightly different, or the spring rates in the caliper were slightly different. You wouldn't accept it. But we don't have that problem. Have you ever received two rear mechs and thought, oh, that one's a bit stiffer on the lever because maybe the spring or the pins in the parallelogram are different? No, you just don't have that problem. So if those guys can produce seriously high quality components with high repeatability, you should be able to make a plastic frame with no moving parts, okay? And like, it pisses me off because some people, you know, flutter money on bikes, okay? You might have high wealth, you know, wealthy customers, okay? And for them, yeah, 5-6 grand isn't a lot of money. But you do have a serious allegiance of loyal fans at a lower pay grade, a lower salary, who will literally save for 2 years to buy the frame that Van der Poel rides or buy the frame that Valverde rides. And it's not acceptable for them to receive something which isn't finished, okay? So if you've got a known issue with a seat post, or you haven't finished the tooling for the plastic injection moulded component, don't release it and don't charge the money for it until it's ready, because this is Shimano engineers, Campy engineers I pity them. They have to hang these quality parts on something that is a bag of crap. If they can get all those tolerances right and all those little nuances right about their production, which is way harder to do than make a carbon frame, and you can't get a frame where the seat post doesn't damage itself inside the frame, or you can't align a bottom bracket shell, I mean, come on, we might as well just give up. Or give the money to Shimano and get them to start making the frames. Come on, this is ridiculous. This sport, this problem is driving me out of the sport. It winds me up no end. That it's embarrassing that we have to spend the money on the crap frame in the middle, which hangs everything off it, which is quality. Arguably, it's harder to make a Continental tyre than it is a frame. And the repeatability of Continental tyres, or any tyre, you think about the tolerance, the geometric tolerance of the bead, the wire bead or the Kevlar bead. You think about the consistency of the materials, low friction, high grip. Durability lasts for thousands of kilometres. It's a safety critical component. They have better repeatability in manufacturing than your carbon frames. And anyway, going back to like the rubber grommet thing, Canyon, if you're going to use an excuse that you didn't have the tooling ready in time, send me the 3D file. I'll get you that made 1 week after Chinese New Year. 1,000 off, 2,000 off. Just tell me the quantity, I'll get it done. Yeah, just send me the file, send me the sure hardness you want. That's all you need. Like, why haven't you done it? Why aren't they being shipped already? Don't use the excuse of pandemic, because in my professional career I was using Chinese suppliers throughout 2020, and I've been using them in 2021, right up until last week, Chinese New Year. Everything's open. Most things are still shipping. What's going on? And there was a big delay in the Aeroad release from when we saw the Zwift adverts, from when we saw Valverde riding it, way back at the beginning of last year. So what was going on? Did you know about this problem? And you came up with some sort of interim solution and decided to ship it anyway? Well, you shouldn't have done, because the last bike was much better and you should have just carried on selling that until you had this problem fixed. Anyway, rant over, riot act red, thumbs up, whatever, subscribe, whatever. Come back for more if you like this kind of thing. See you in the next one.